Hello everyone, in this video I will discuss about lookup table and I will create lookup table for sine function, and in the end of the video I will create sinusoidal waveform with this lookup table. In the first step you should build your table. I call it sine table with index. So, what is this index? The index of sine table is your resolution. The math library of C calculates sine and cosine values on radian scale, and the range of radian scale is from 0 to 6.28, and we divide this range to index value. If we gave 1000 to the index of sine table, our resolution will be 6.28 divided by 1000, and it will be 0.00628. Also, you can increase resolution more than 1000, but it will take more RAM space from your microcontroller. 1000 is good trade-off between resolution of table and required space of your microcontroller. Now we can produce our table values. I really recommend that fill table before entering main while loop. This code will occupy your microcontroller time. For this purpose, I use a for loop, and the body of for loop is like this. And this for loop should be executed for 1000 times. It's our resolution, and yeah, it's done. We should calculate sinus of each point of our table. So sine table with index of I equal to sine function from math library I multiplied by our steps. What is our steps? It's 0.00628. And it is done. So the output will on radian scale. And if you want to convert it to degree scale, you should take copy from this, and this part of code should be divided by p and then multiplied by 118. And this function will give you output on degree scale. I commented this part of code for now, and I forgot to include math library, and it's done. So we create our table. In next part of video I will show you how you can use it. So we create one array with 1000 elements, and we divide our radian scale to 1000 points and fill each point with this function. For start, I create one variable with name of AC and the initial value of 2. I want to calculate the sinus of AC in radian scale. So how I can do this with lookup table? In first look, you may think you can write code like this, but it's truly wrong. So this is not correct. For finding corresponding numbers, you should multiply your number with 1000 divided by 6.28 with this number. You should multiply AC with 159. This time the index of sine table should be multiplied by 159. Sometimes the index of sine table will be float, but the arrays can't accept float numbers, So you should cast this number to integer type, and yeah. Now we can check the result. Alright, this time we can debug our code. You need to add some delay to your code and go to the debug configurations, and from this menu you should to check the enable live expression and click the debug button. Alright, go to the live expressions. If you don't have this menu, you can add this from Windows menu and show view. Yeah, it is live expression. We need to add our value here, and you can run your code from this button, resume. Alright, the sinus of 2 in radian scale is 0.9. Now we can check and compare our code with calculator, and the sinus of 2 in radian scale is 0.909. So it is so close to our table value, and this is done. Let's check what happened in this code. We create one array with 1000 elements, and as I tell before, this 1000 index is your resolution, and we fill this array with this function, and this function will give us the sign values for every element is exist in this table. So guys, this is done, and I'm sorry for any glitch or errors in my speech. It is not my native language, and in next episode of this video we will create sinusoidal PWM with this lookup table. Like, subscribe and share this video if you like it.